Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to look at EMR, or Elastic Map Reduce. Now, this is the industry-leading cloud big data platform for processing vast amounts of data using open source tools such as Apache Spark, Apache Hive, Apache HBase, Apache Flink, Apache Hoodoo, and Presto. And with EMR, you can run petabyte scale analysis at less than half the cost of traditional on-premise solutions and at over 3 times faster than standard Apache Spark. So all EMR is a solution for big data that's hosted within AWS. So if you have any kind of scenario-based questions talking about big data, I want you to immediately start thinking about Elastic MapReduce. And the central component of Elastic MapReduce is the cluster. And a cluster is simply a collection of Amazon Elastic Compute Cloud, or EC2, instances. Now, each instance in the cluster is called a node, and each node has a role within the cluster, and this is referred to as the node type. So EMR installs different software components on each node type, giving each node a role in a distributed application like Apache Hadoop. So let's look at the different node types. We'll start with the master node, and this is a node that manages the cluster. And the master node tracks the status of tasks and monitors the health of the cluster. And every cluster must have a master node. The smallest cluster that you can have is 1, and that will consist of a single master node. We then have our core nodes, and a core node is simply a node with software components that run tasks and stores data in the Hadoop distributed file system, or HDFS, on your cluster. And multi-node clusters have at least one core node. And then we have a task node, and this is completely optional, but a task node is a node with software components that only runs tasks and does not store the data in HDFS. And like I said, they are optional. So this might be what an EMR cluster looks like. We've got here our master node, we've got our core nodes around here, so we've got 4 different ones, and they can each communicate with each other. So that's key to know. Now, the thing about EMR is with all your log data, it's stored here. It's stored on the /mount/var/log. And the problem is if you lose your master node, it's stored within that master node. So you're going to lose all your log data. So if you have an outage or somebody goes in and terminates that cluster, you are going to lose that. And that can be problematic. And what you're going to see in the exam is scenarios where it's talking about you've got an EMR cluster and you need the logs data on your master node to persist. What should you do? Well, essentially what you do is you move your log data over to S3. So you can configure a cluster to periodically archive the log files stored on the master node to S3. And this ensures that the log files are available after the cluster terminates, whether this is through a normal shutdown or due to an error. And Amazon EMR archives the log files to Amazon S3 at 5-minute intervals. Now, it's important to remember that you can only set this up when you're first creating the cluster. You can't create the cluster and go do this later. You need to do it when you first set up the cluster. So it can be a very popular exam topic. I just want you to remember that you can persist your log files to S3, and you need to do that when you set up the cluster. So going into the exam, just remember that EMR is used for big data processing. It consists of a master node, a core node, and optionally a task node. By default, log data is stored on the master node, and you can configure replication to S3 on 5-minute intervals for all your log data from the master node. However, this can only be configured when creating the cluster for the very first time. So that is it for this lecture, everyone. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus and welcome to this lecture. So congratulations, you're at the end of the databases section of the course. In this lecture, we're just going to summarize everything we've learnt about our databases. So we learned about RDS. This is used for online transaction processing. Comes in 6 different flavors. We've got SQL Server, MySQL, PostgreSQL, Oracle, Aurora, and MariaDB. We then have Amazon's DynamoDB service. This is a NoSQL database service available to us. We are going to create our own DynamoDB table in the serverless section of the course. We'll get more hands-on with that. We then learnt about Redshift, Amazon's data warehousing solution, and this is used for online analytics processing. We then also learnt about Elasticache. This comes in 2 different flavors, Memcached and Redis. Memcached is used if we want something very, very simple, whereas Redis is used for more advanced data types and if we need multiple availability zones or if we need to be able to do backups. In terms of relational databases, just remember the following points. RDS runs on virtual machines and you cannot SSH into these operating systems. You cannot log in, so you can't RDP using Windows and you can't SSH to your Linux operating systems. And that is a really important point to remember for your exams. Patching of the RDS operating system and database itself is always going to be Amazon's responsibility because you do not get operating system level access. Remember that RDS is not serverless. However, there's an exception to the rule. There's Aurora serverless, and that is serverless. So almost everything in RDS is not serverless, with the exception of Aurora serverless. DynamoDB is serverless, however. Remember, there's 2 different types of backups for RDS. We've got automated backups, and then we've got our database snapshots. So moving on to read replicas. Read replicas can be multi-AZ, and they are primarily used to increase performance. And this is a very common exam scenario. Basically, you've got a struggling database. It's got very heavy read traffic. Maybe it's a WordPress blog or something like that. How do you increase, the performance on that database? And one of the answers is, of course, to add read replicas and to point your EC2 instances to those read replicas. Just remember to enable read replicas. You must have backups turned on. And read replicas can be in different regions as well as the same region. So you can have read replicas around different regions in the world. And read replicas can be MySQL, PostgreSQL, MariaDB, Oracle, and Aurora. The only database engine or RDS engine that doesn't support read replicas at this time is SQL Server. And remember that read replicas can be promoted to a master, but when you do this, it's going to break the read replica. So it's going to break the replication. Remember that multi-AZ is used for DR only. It is not used for performance, and you can force a failover from one availability zone to another by rebooting the RDS instance. Remember that encryption is supported for MySQL, Oracle, SQL Server, PostgreSQL, MariaDB, and Aurora. Encryption is done using the AWS KMS service or key management service, and once your RDS instance is encrypted, the data stored at rest in the underlying storage is going to be encrypted, as well as when you do automated backups, read replicas, and snapshots, they're also all going to be encrypted as well. DynamoDB, serverless, like I said, it's stored on SSD storage. It's spread across 3 geographically distinct data centers. You have 2 different types of consistency. Remember the 1-second rule. So you've got eventual consistency. So if your application doesn't need to read your updated data within 1 second, then you want eventual consistency, and this is what you get by default. If, however, your application needs that data to be updated, it always has to have a perfect copy of the data, and certainly within less than 1 second, then you probably want strongly consistent reads. Moving on to Redshift. Redshift is used for business intelligence. It's only available in one availability zone right now. When you're doing backups, Redshift has backups enabled by default with a 1-day retention period. Just like with RDS, you can extend this retention period to 35 days. Redshift will always attempt to maintain at least 3 copies of your data, the original and replica on the compute nodes, as well as as a backup in Amazon S3. Remember that Redshift can also asynchronously replicate your snapshots to S3 in another region for disaster recovery. So moving on to Aurora. Remember going into your exam that 2 copies of your data are contained in each availability zone with a minimum of 3 availability zones. So you're always going to have 6 copies of your data. You can share Aurora snapshots with other AWS accounts, and there's 3 different types of replicas available. You've got your Aurora replicas, your MySQL replicas, and your PostgreSQL replicas, and automated failover is only available with Aurora replicas. Remember that Aurora has automated backups turned on by default, and you can also take snapshots with Aurora, which is what I said earlier, and you can share these snapshots with other AWS accounts. And then finally, remember that to use Aurora serverless if you want a simple, cost-effective option for infrequent, intermittent, or unpredictable workloads. Elasticache. So remember that you use Elasticache to increase database and web application performance. It does this by caching. If you need multi-AZ, then you're going to be using Redis. If you need backups, then you're going to be using Redis. So that is it for this section of the course, guys. If you have any questions, please let me know. If not, feel free to move on to the next section. Thank you.